So next up, we are going to look at graphing trig functions. All right, now there's kind of a lot to graphing trig functions, so we're going to kind of take it in pieces. Today, we're just going to talk about the vocab and the different things that you're going to need to be aware of when you're looking at these trig functions. And I'm going to give you a function, and just you need to be able to look at it and tell me what are all these different basic vocab words. Okay, so let's start by talking about the amplitude. Okay, so when we talk about the amplitude of a trig function, what that is it's the distance from what we're going to call the midline. So the distance from the midline to the top or bottom of the wave. Okay, so as an example, we're going to use sine graphs in our examples as we do these. Okay, so here's my graph. So my sine curve is going to look something like this. Okay, so when we talk about what the amplitude is just the distance from the midline. And the midline is just, you kind of see how it there's a balance point between the peaks and the valleys, right? That's sort of along the x-axis on this one. That's what your midline is. It's in the middle. Okay. So we're looking at our distance from there to the top or bottom of the wave. So that would be this distance here, or you could measure this distance here. They will be the same. Okay, so that's always going to be the same on your graph. Okay, so that right there, that is going to be what your amplitude is. Okay. All right, now as we do this, we are going to be flipping back and forth between pages. So now that we've talked about the amplitude, all right, we're going to flip to our next page, and I want to take a look at some examples. Okay, so here we've got this graph. The first thing that I want to do is just look at this and say, okay, where's my midline? Well, on this one, my midline is kind of right here, right? It's right in the middle. You can see it's kind of the distance to that peak and valley. So to measure my amplitude, I'm looking for that distance or that distance. Make sure you just check what your axes are numbered by. These are by ones. So this is a distance of 1, 2, 3, or 1, 2, 3. It's the same. So my amplitude for this guy is just 3. All right, this guy here, my midline is in the same spot, right? It's along the x-axis. So my amplitude is going to be either this distance or that distance. So one of those two, they're the same, and you can see that that's one block. So I have an amplitude of 1. Okay, this guy down here, my midline, again, is along this x-axis. We'll see one in a minute where it's not. And my amplitude here or here goes to 1/2. So this one's got an amplitude of 1/2. All right, this guy here, there's my midline. So my amplitude is either that distance or that distance. So that's 2. Okay, and you're noticing that these are always positive, I hope. Okay, this guy right here, here's my midline. So there's my amplitude, which is just 1. All right, this guy, there's my midline. Here's my amplitude. So again, that one's just 1. All right, at this point, I want you to pause the video and see if you can do the next 2 on your own. Okay, you should have just unpaused the video after you paused it to do the next 2 on your own. So let's check them. So here's my midline, and my amplitude is going to be 2 for this one. So that one, your amplitude's 2. This one, here's my midline. All right, and my amplitude is also 2. All right, and these last 2, the only thing that's different about these is that our midline is not in the same spot. All the ones we've done so far, the midline's been on the x-axis. This one, it's not. So you're just going to have to kind of look at it and figure out, okay, here's my peaks and my valleys. Where's the halfway point between those, right? So if I kind of count up, I can see that this is the halfway point. So that's where my midline is. Okay, so that's what you want to count from. It's not always from the x-axis, it's from your midline. So I can see here, there's my amplitude, or there's my amplitude. So that's an amplitude of 2. All right, same thing here. I want to kind of figure out, okay, the halfway point between these two. You can just sort of look at it and find halfway, or if you need to, add together the 2 numbers, your maximum height and your minimum height, and divide by 2. That's how you find halfway, right? So 5 plus negative 1 would be 4, and half of 4 is 2, so my midline is at 2. Okay, and then I can find my amplitude pretty easily. My amplitude is 3. Okay, great. All right, so that's the first thing that we're dealing with. That's your amplitude. All right, so now we're going to flip back to the first page and we're going to talk about our next vocab word, which is the period of a graph. Okay, so when we talk about the period of a sine or cosine or tangent function, what that is, it is the horizontal, not vertical, so the horizontal length of one complete cycle. Okay, so a horizontal length of one complete cycle. So let's talk about what that's going to look like. So I'm going to draw a graph here, and I'm going to try to make this one a little bit longer. So this is what these waves do, right? They just kind of keep going forever. But if you can kind of look at this, you can sort of see that there's a spot where it starts like repeating itself. Okay, so like if I start at this point right here, right, at 0, 0, I'm at a spot where I'm on like the midline and I'm going up, right? And if I look here, here's another spot on the midline going up. So if you kind of look between those 2 points, that little piece of the wave, okay, that is one complete cycle. And I can tell it's one complete cycle because if I were to like use my computer to draw a box around that and copy and paste this by itself over and over and over and over, you would get this entire graph. Okay, so that's how you know that you have a complete cycle. It should be something that if you were to copy and paste it on a computer next to itself again and again, that it would give you the correct looking wave. If I had just done, like if I just did this section here and copy and pasted that, it wouldn't look right because it would just be like bumps over and over again. You wouldn't have that downward swing. Okay, so what your period is the period is the length of one complete cycle. So for this particular graph, my period would be from here to here. Okay, that would be the length I would measure to find my period. Now, I used this point on the midline, but it doesn't necessarily have to be. Okay, so I went from this point to this point, but we could have also done, say, from the peak to the next peak, right? If you kind of took that piece and you copy and pasted it over and over again, you'd get the same wave, right? So you could also use this as your period. There's an infinite number of spots where you could start and stop, right? I could have started here and then stopped here. That would give me a complete one. You just got to make sure, oh no, I'm sorry, that's the wrong spot, here and here, right? You just got to make sure that if you copy and pasted that, you'd have the entire correct looking graph. Okay, so either one of those could be used as your period. All right, so let's go ahead and look at some examples of this. So I'm going to flip to my next page. I'm trying to flip to my next page. Eventually, I will get to my next page. Here we go. Okay, so we are now going to look at the period of each of these graphs. Okay, so looking at this first one, when I want my period, I'm going to take a look at this and just try to find the easiest way that I can measure, okay, how long is this thing? All right, so looking at this graph, I'm going from here to here. That's a pretty easy spot, I think, for me to find my period. It's the peak of one to the peak of the next. And I'm starting at 0 and ending at 360. So the length of that is just 360 degrees. So the period for this function is 360 degrees. All right, so that distance right there, that's what I measured. When we look at this guy, right, here's a spot where I'm on my midline and I'm going up from there, right? So I need to find another spot on the midline going up. I can't use this one because that's on the midline, but it's going down, right? So this would be a spot on the midline going up. And then I just want to measure what is that distance. Let's see, this is 60, that's 120, so this would be 90 between. So I'm going from 0 to 90, so my period is 90 degrees. Okay, this guy down here, I can use this as a starting point on the x-axis going up. Here's another spot on the x-axis going up. You're going to notice that this one is labeled in radians instead of degrees. That doesn't make a difference. Okay, it just means that our period is going to be 4 pi here. All right, this guy here, here's a spot on the x-axis going up. Here's another spot on the x-axis going up. So I'm measuring that distance there. I'm going from 0 to 8 pi. So my period, is 8 pi. All right, one's on the back. So this one doesn't start at 0, 0. That's okay. So I'm going to go from the top of a wave to the top of the next wave, and that's totally cool. All right, you just have to make sure that you're in the same spot. I like to try to choose a point if I can on the y-axis, because then I don't have to deal with, well, how far away are these 2 points? Like I could go from here to here, but then I'm going to have to do some math to figure out how far away are 360 and 1080. So I usually try to start on the y-axis and end wherever it needs to end, because I just think that's a little easier. So this one, my period would be 720. Okay. All right. This one right here. So here's a starting point. Here's an ending point. So that distance is 120. So my period's 120 degrees. All right. So pause this video. Try finding the period for the next 4. All right. You should have just unpaused this video after having paused it. So let's check and see if you were right. So here's a spot. I'm on the midline going up. So here's another spot on the midline going up. And the distance between those two is pi over 2. So there's my period. All right, this guy here on the midline going up. Here's another spot on the midline going up. So the distance between those two. All right, this one's a little bit weird. So I have to find, let's see, this is pi over 2, and that's 3 pi over 4. I need to find halfway between this. So this is the same thing as 2 pi over 2. So if that's 3 pi over 2, oh wait, hang on. Sorry, I'm trying to read this. I can't really tell from my graph from the way that it printed. I'm not sure if that's on 3 pi over 2 or halfway in between. So I'm a little bit thrown off by this one because I can't see the background lines to know what that measurement is. So I'm going to call it, I think I'm going to just call it 3 pi over 2 because I'm honestly not sure. Okay, so take that with a grain of salt. I'm having trouble just like seeing this to know where that point is exactly. Okay, all right, this guy down here. So here's a starting point, here's an ending point. So I want that distance. That has a really big period, so 1,440 degrees. All right, and then here's one that's kind of weird, right? So like I said, I usually like to start on the x-axis because I find that a convenient thing to do. But if you notice that here, it doesn't really go through a nice point. And if I try to look at like, all right, so here's like my starting point, then my ending point on the wave would be like here, right? And that, I'm not sure if that's on a line or not. I genuinely can't tell. It's the same thing as this one. I can't tell if it's printed. Okay, so this one's a little bit harder to do. Don't really stress about that. If I ask you to identify for me what the period is, I'm not going to give you one that's super hard and ask you to like do something really, really bad with it, okay? So don't stress about this one. I'm actually just going to skip this because the point of this is not to see if you can like carefully measure the distance between these little things and estimate it. The point of this is just to see if you can tell me what the period is and find that from a graph. Okay, so don't stress about that one. All right, so that is our period. That is thing number 2. Okay, so next, let's go back and talk about a phase shift. Okay, so if you remember phase shifts, if you remember doing in Algebra 2, your transformations of functions where you would shift to the left or right on a graph, that's what a phase shift is. Okay, so it's a left or right slide on your graph. So a left or right slide of your function. Okay, now the key thing with this, and we're going to talk about the difference between these two later, but just make a note to yourself that you really have to make sure that you pay attention, okay, to if it's a sine or a cosine graph. Okay, so you have to pay attention if it's a sine or cosine graph. Okay, why? Well, because a sine graph starts at 0, 0, but a cosine graph by default starts at 0, 1. Okay, so figuring out what kind of a phase shift you have really depends on what kind of graph you started with. Okay, now for the sake of making our lives easy, we are going to assume that every graph in these examples is a sine graph. Okay, so we're assuming it's a sine graph and it's supposed to start at 0, 0. So when I'm looking for my phase shift, all right, my graph is supposed to start here. This is supposed to be the spot where it starts from and it goes up from. But that's not what's happening here. That point's actually way over here. This is the spot. That's the spot where it started from and it's going up, right? It's on the x-axis going up. So what that's telling me is that basically this whole graph has been slid over. Okay, how much has it been slid over? Well, the point that was supposed to be at 0 is now at 270. So this has a phase shift of 270 degrees. Okay, this guy here, and again, we're assuming these are all sine graphs. So sine graph is supposed to start at 0, 0 and go up. This one does that. Awesome. That means that I have a 0 phase shift. Okay, this guy down here, my graph is supposed to start at 0, 0 and go up. It does. So my phase shift is 0. Supposed to start at 0, 0 and go up. It does. So phase shift is 0. Not a ton of phase shifts on that page. All right, but now we're going to start seeing a few more. All right, so this guy, I'm supposed to start at 0, 0 and go up, but I don't have that happening here. So I need to look along my graph and find where's there a point that's on the x-axis and going up. Well, that's here. It's at, what does that say? I can't tell what that says. I think it might say 640. I'm going to go with 640. I can't really read it. Okay, so that's a phase shift of 640 degrees. Okay, the whole graph has been pushed over sideways. Okay, this guy right here is supposed to start at 0, 0 and go up. It doesn't, but here's a point that does. Okay, so that looks like it's at about 90 degrees. So that's a phase shift of 90. All right, now you may be thinking to yourself, but Miss King, there's another point over here that also starts on the x-axis and goes up. So how do I know that it's a phase shift of 90 and not a phase shift of whatever this number is, right? Or isn't there a point over here too where it's on the x-axis and going up? How do I know it's not a phase shift of negative 30? Well, you don't know. Okay, so the truth of it is that you can't tell just from looking at a graph what exactly the phase shift is. Okay, so I'm just going to ask, like, if you give me one that would work, then you're fine. So if you had given me negative 30 instead of 90, I would have accepted that as a fine answer. Okay, it's when you're going the other way where I'm going to give you an equation and then you have to graph it. That's where what the phase shift actually is will be more important. All right, so having established that, pause this video, try the phase shift for the next 4. All right, in theory, you pause this video and started the phase shift for the next 4. So let's look at these. So this guy right here starts at 0, 0, goes up like it should. That's a phase shift of 0. This one starts at 0, 0, goes up like it should. Phase shift is 0. This guy down here, now here's the thing. This one's got to move to midline, right? So the point doesn't actually have to start at 0, 0. I've been saying that incorrectly. It should start on your midline. So my point's supposed to start on my midline, right? And the y-axis. So I'm looking for a point that was supposed to be here and going up. So where's that point been moved to? Well, it's over here now. So this one has a phase shift of 1080. Okay, over here, I'm looking for a point on my midline and going up. So that would be here. And again, for the sake of making our lives easy, I'm just going to call that pi over 2. I'm not 100% sure if that's actually where it is because I can't see that line there, but we're going to call it pi over 2. And again, I won't give you something that's like ambiguous like this. It'll be really clear if I ask you for one of these. All right, so that is a phase shift. That one's pretty easy. All right, now the next one is a vertical shift. All right, and a vertical shift is equally easy. Okay, so all that a vertical shift is it is an up or down slide. So the shift part tells you it's a slide, and the vertical tells you that you're going up or down. All right, and you always just want to check this against the midline. So we're going to check it against the midline. Okay, so you look at where your midline is and compare that to where the x-axis is, and that'll give you your vertical shift. So as you may be able to guess, we're going to have a lot of vertical shifts of 0 here. Here, my midline is on the x-axis, so no vertical shift. Midline's on the x-axis, no vertical shift. Midline's on the x-axis, no vertical shift. Midline's on the x-axis, no vertical shift. We're flying through these, right? This one, this one, this one, this one, all have their midline on the x-axis, so they all have a vertical shift of 0. Okay, it's these last 2 that are going to have a vertical shift. Okay, so when I look at this one, my midline has been moved up to 1, so that has a vertical shift of 1. This guy, my midline's been moved up to 2, so it's got a vertical shift of 2. Okay, so that is really easy to figure out. All right. We're getting there. So we've got one more thing that we need to talk about, which is the frequency. Okay. And again, all that I'm expecting you to be able to do right now as of this lesson is just be able to look at a graph and identify these different pieces. Look at it and tell me what's the amplitude of the graph. Okay. What's the period of the graph? What kind of shifts has it had? And then finally, what the frequency is. Okay. So frequency, what frequency is, sorry, I had to find a different color marker. Okay, so the frequency is the number of cycles in a given interval that, depending on what your measurements are, if you're in degrees, it'd be 360. If it's in radians, it's 2 pi. Okay, so essentially a complete loop of the unit circle. So when you do a complete loop of the unit circle, how many cycles are actually completed? Okay, and then a couple of little baby formulas that you're going to want to know, right? If you are in radians, if you do 2 pi and divide it by the period that we talked about up here, okay, so 2 pi divided by the period will give you your frequency. And similarly, if you're in degrees, 360 degrees divided by your period will give you your frequency. Okay, so that's kind of a shortcut. But here's what we're actually measuring. So here's an example. So when I have my graph, this is one complete cycle, right? I'm not going to draw the whole thing. That's one complete cycle. If we copy and pasted that, right, that would give us the complete graph. So this is the period of our graph. So what you're looking for is you're saying, okay, here's where 360 is. How many complete cycles are there between 0 and 360? In this case, 1. So my frequency would just be 1. All right, but as a different example, if I gave you a graph, and again, I'm not going to draw quite the whole thing, right? So if I gave you a graph like this and I told you that this is where 360 is, well, then I would look at this and say, okay, well, here's one complete cycle. And then from there, here's a second complete cycle. So between 0 and 360, there's 2 complete cycles. There's 2 complete like copy pastes of this graph. So my frequency is going to be 2. Okay? So that's what this is going to look like. If you were calculating it using this little formula where you're doing 360 divided by the period, well, the period for this one would be 360 because that's how far it takes you to complete a full cycle. So it would just be 360 divided by 360, which is 1. This one, right, you would have to know that this was at 180. One complete cycle is at 180. That's the period. So my little formula says do 360 divided by the period, which is 180. And that's where the 2 comes from. Okay, great. So let's look at some examples here. Okay, now we've already figured out our period for these, so that's going to be helpful for us. So what I'm looking for is between 0 and 360, how many complete cycles have there been? Well, 1, right? So my frequency is just going to be 1. Okay, or I could do the fact that I know that it's 360 degrees divided by the period that we figured out up top, right? And that's where the 1 comes from. Okay, this guy here's 0. 360 is way over here. So I'm counting how many complete cycles are there. Well, here's 1. Here's 2. There's 3. There's 4. So my frequency here is 4. There's 4 complete cycles between 0 and 360. Okay, or I could have done 360 and then divided that by the period that we found, 90. Okay, and that would have also gotten us our answer of 4. All right, this guy down here, this one's in radians. So instead of looking at 360, I'm looking at 2 pi. So I'm going to look at this and say, okay, how many complete cycles do I have between 0 and 2 pi? Well, that's only a half a cycle. There's the full cycle. So this right here is half of a cycle, right? So my frequency is only going to be a half here. Okay? Or I could have done, again, 2 pi, that's a complete circle, and divided that by the period we found before, which is 4 pi. So the pi's would cancel each other out, and 2 over 4 simplifies to a half. All right, this guy here. So here's 0, there's 2 pi. So how much of a cycle do I have? Well, here's a complete cycle. Here's half of a cycle. That's half of a cycle. So that's a quarter. You get a quarter of this graph between 0 and 2 pi. So my frequency is 1/4. Okay, or again, I could do 2 pi divided by the period that we found, 8 pi. The pi's would cancel. 2/8 simplifies to 1/4. So that's my frequency. Frequency, I think, is the most complicated of them all, but it's not awful. All right, so this guy, here's 0, here's 360. How much of my complete cycles do I have? Well, that's only half of a cycle, right? Here's the complete one. This is half of it. So my frequency is 1/2. Or I could have done 360 divided by 720, and that would have gotten us to the same place. Okay. This guy right here, here's 0, here's 360 over here. So that's 1 complete cycle, 2 complete cycles, 3 complete cycles. So my frequency is 3. Or again, I could do 360 divided by my period of 120. That's going to get me the same answer. All right, now pause this video, try the next 4. Hopefully you just pause this video and try the next 4. So let's take a look at them. So this guy right here, here's 0, and this is in radians, so I want 2 pi way over here. So how many complete cycles? That's 1. That's 2. 3. 4. And that's it. That's 2 pi, right? So I have 4 complete cycles. So my frequency is 4. Or I could have done 2 pi and then divided by my period of pi over 2. If you don't remember how to divide fractions, what you're going to do is you keep the first one the same, and then you flip the second one and multiply it, right? That's a weird pi. I can stick a little 1 under that 2 pi, right? Multiply straight across, and I'm going to get 2 times 2 is 4, and the pi's would cancel. So 4 pi. All right, this guy here, here's 2 pi. Here's the start of my cycle. So that's 1 cycle, 2 cycles, 3 cycles. So my frequency is 3. Or I could do 2 pi divided by 3 pi over 2. And again, we keep the first one the same, change it to multiplication, and flip the second one. Oops. There we go. That's flipped. Okay, so the pi's would cancel each other out. 2 times 2 would be 4. And 4 divided by 3, something's the matter there. Oh, you know what it was? It was because this one we sort of estimated. Oh, it's because I wrote the wrong thing here, right? That was supposed to be a 4, not a 2 at the bottom. So then that would be a 4. It's still not going to be perfect because this is the one that we estimated where the point was. So that's why this is a little bit off. Don't stress about that. Okay. This guy right here, here's 360. From here to here, that's a quarter of a cycle. So that's 1/4. Sorry, the announcements are going right now. Okay. And again, my period there, the other way I could calculate it would be 360 divided by that 1440 we already found. And that's going to give you your 1/4. This one we're going to skip because we did the same thing with estimating our period for this one, so we're not going to worry about the frequency. Again, when I give these to you, I'm not going to try to make them really difficult, so don't stress about that, okay? All right, so that is everything that we have for vocab. Okay, so again, all that you should be able to do right now is just look at a graph and identify these things. Okay, so that's what you want to practice. We'll go forward and work on actually graphing them as we kind of move on.